Hello everyone, welcome back to my channel. So today we have this integral function that is actually in front of us to integrate today. How are you going to be integrating this kind of functions when you come across them? That is what I'm going to be showing you how you can do in this video. And so just as we proceed in the video, if at any point you start getting value in the video, you can actually do well to subscribe to our channel and also turn on the notification icon so that you will always get notified each time we release new content. Okay, so and having said that, we're just going to proceed. So for this kind of functions, for you to actually integrate it, you will need to do some trigonometric substitutions, and that is when you are going to be. So let me just write a solution and then repeating this integral. Okay, root a squared minus s squared dx. So you are going to be setting your x to be this trigonometric function, which is a sine theta. Okay, so this is what you are going to be setting your x to be, and once you do that, you see you differentiate x with respect to theta, and if you do that, you'll be having a cos theta. Okay, and of course here you're gonna be seeing that the x will now be equal to a cos theta d theta. So this is what your dx is going to be. So what we are going to be doing now is just to begin to do some substitutions in the equation. So our integral root a squared minus sine squared dx will now be equal to integral root our ax minus our x is actually a. Okay, so but because our x is carrying squared here, we are going to be squaring this thing right here. So we are going to be having a squared sine squared theta, and then multiplying our dx. So the x is now a cos theta d theta. So this is what we have now. Okay, so moving on, we can see that we can evaluate that further. This is integral root a squared is actually common there, so we can bring it out, and then we have the one inside bracket to be 1 minus sine squared theta. Okay, and of course multiplying our dx, a cos theta d theta. Okay, now what do we do again? We know this thing inside this bracket here, because if you remember the identity, sine squared theta plus cos squared theta is actually equal to 1. So if we make this the subject right there, you see that our cos squared theta is equal to 1 minus sine squared theta. So we are going to replace this with this one right here. So doing that, this now becomes integral a squared cos squared theta. Okay, multiplying by our dx, which is a cos theta d theta. Okay, so I hope you guys are getting it. It's just pretty much simple, just for you to follow the process we are going through. Okay, now what do you do again? Moving further, we can actually rewrite this thing we are seeing right here to be integral root a cos theta and all in squared, because both of them are having squared right there. So multiplying our dx, which is a cos theta d theta. Okay, so these two can actually cancel this square root, so that we now have integral a cos theta d theta. So this is what we have at this moment. Now moving forward, we can multiply these two, and then we are now having integral a squared cos squared theta d theta. Okay, now as we proceed, we can actually factorize this out, because this is actually a constant. So if you do that, we'll be having a squared integral cos squared theta d theta. Okay, so what we are going to be doing now is to also make another substitution, which we know so well. Of course, if you remember, our cos squared theta can actually be written as cos 2 theta plus 1 all divided by 2. Okay, so we are going to be making this substitution right here. So doing that, our integral now becomes a squared integral cos 2a 2 cos 2 theta plus 1 divided by 2. Okay, and of course our d theta is also here. So we are going to be integrating this function, but before that we can also factorize our constant, which is half right here. So factorizing the constant half, we have a squared divided by 2 integral cos 2 theta plus 1. Okay, so we have the theta right here. So what we are going to be doing now is just to integrate direct, and if we do that, what we are going to be having is a squared divided by 2. Okay, so integrating this one, we have that this is equal to sine 2a divided by 2 plus, if we integrate 1, we'll be having theta. Okay, and then plus our constant of integration. Okay, so moving further, we can continue to make some substitution. If you remember that sine 2a can also be written as 2 sine 2 theta, rather can also be written as 2 sine theta cos theta. Okay, so we're going to carry this to actually replace this, and if we do that, what we're going to be having is a squared divided by 2 into 2 sine theta cos theta divided by 2, and then plus theta plus our constant of integration. These two can actually cancel these two, and then we are having that a squared divided by 2 sine theta plus, okay, sine theta cos theta plus theta, okay, plus c. So this is our final answer, unless you may also want to open the bracket. You are now going to be having a squared over 2 sine theta cos theta plus a squared over 2 theta, and of course plus, this is plus our constant of integration, and of course this is where we are going to stop. And so if you have enjoyed this video, ensure you give this video a thumb up, subscribe to our channel for more of this, and of course I'm going to see you guys in my next video. Bye.